Welcome back to another video on my channel, math_exe. Today we're going to look at more, I would say, tricky examples of these. And just a further disclaimer, these examples may involve some unknown tricks that I haven't mentioned in my past videos. So you may just try some couple of questions for your own and then just follow up for the answers if you're ready. Alright, anyways, question 1 is says we need to find the gradient and the equation of each lines right here. So for part A is pretty simple. The gradient is just rise over run. And first I'm just going to take point B as our second set of coordinates. And I'm going to take point A as our first set of coordinates. So what that means is we can just plug in 2, which is the y-coordinate of B, minus -4, the y-coordinate of A, over 6 minus 4. And this will give us 2. And for the equation is also not that bad, because remember our Poinsot formula is something like y equals mx plus b. M is the gradient in this case, which is 2, and b is the y-intercept that we need to find in this case. So temporarily we have this equation, and to find the y-intercept we can just substitute the coordinates of either point A or point B, but I'm just going to do point A. So the y-coordinate of A is -4, and the x-coordinate of A is 4. And plus B, so we have -4 equals 8 plus B, which leaves us B equals -12. So that means plugging in B back to our original equation, it will be y equals 2x minus 12. So this is the gradient of the line, and this is the equation of the line. Alright, for part B, a line is parallel to the line blah 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 and passes through point blah blah blah. And we know when two lines are parallel to each other, for example line 1 and line 2, and they are both parallel, the gradient of line 1 is equal to the gradient of line 2. So using that property, we know that the unknown gradient of our line will be 2. And just like part A above, we just set up our Poinsot formula and then later on substitute the coordinates of t in this case to find B, which is the y-intercept. And then we have point T at 1, 3. That means y is at 3, and then x is at 1. And then solving for B, we'll get B is equal to 1. So substituting that back in, we'll get the equation of the line is simply y equals 2x plus 1. And that's it. For part C is pretty tricky, and I haven't mentioned this property in the past videos. So given we have 2 lines, I'm just going to draw a xy plane real quick. So given we have 2 lines, something like this, and something that looks like this, and they are perpendicular at the point of intersection there. So just call this line 1 and then line 2. And then the gradients of these lines are m1 and m2 respectively. And the relationships between both of these is m1 is actually the inverse reciprocal of m2. Or in other words, the gradient of a line is the inverse reciprocal of the gradient of the other line, and given that they are both perpendicular. So what that means, the gradient of our unknown line must be the inverse reciprocal of 0.5, which is simply -2. And all steps after that is just pretty much the same as the other ones, substituting the coordinates of k in this case, which is 1, -3. However, just first set up our points of formula, and we know m in this case is 2, or sorry, -2 x plus b, and then we know our y coordinate for point k is -3, and our x coordinate for k is 1, and this is plus b, giving us b equals -1, which means our equation of our given unknown line will be y equals -2x minus 1. That's it for question 1 in this case. Let's jump into the second one. Alright, for the second question, it's about reading linear functions instead of graphing them. So the following graph below shows the amount of money, and this is a typo right here, shows the amount of money Adam has y dollars after x days. So as you can see, the graph kind of slopes downwards. And then we have these scales on the y and x axis. First, we need to find the gradient of the function above. And when you have this function, you may just want to sketch some lines, or maybe I would say special coordinates from this graph. So what I would like to do is to start off with the x-axis, and I would say I would draw a vertical line intersecting 2 on the x-axis, and I'm going to stop at the function, and I'm going to make a perpendicular horizontal line to the y-axis and see which value the horizontal line lies on, and in this case it's 80. So with this we have the coordinates 2, 80. And then I would just do this for another one. However, for this is pretty simple, seeing as this graph intersects the y-axis at 1, and I would just write this at 0, 100. And when you have two coordinates that lies on a graph, you can just calculate both the gradient and the equation of the line. So the gradient of the line is pretty simple, and it's just this following right here. So I have 80 minus 100 all over 2 minus 0. And this will tell us that the gradient will be -10. And then hence find the equation of the graph relating y and x, knowing that our points of formula is like so. And then we know our gradient is -10, and the y-intercept in this case is already given, which is 100, because it intersects this at y equals 100. So that means the equation of the line must be in the form of y is equal to -10x plus 100. And then for the third one, infer what does the gradient of the function tell. And given it shows the amount of money Adam has after x days and the graph slopes downwards, you can just probably tell that the gradient is probably the amount of money Adam spends per day. So let's just write that out. So -10, which is the gradient in this case, shows us amount of money spent per day. Alright, that's it for part A. Now let's jump into part D. Using the given equation or the graph above to find the amount of money Adam has left after 132 hours. And given that 132 hours is still in hours, while the given x in this case is in days. So we must first convert this 132 hours into days. So given 132 hours is just 132 over 24 days, because one day is 24 hours, and this will give us 5.5 days. Now I can just substitute this value, and this value shows the x right here, or you can just use this graph to find what y is supposed to be when x equals 5.5. So I just draw a vertical line intersecting the x-axis at 5.5. So let's just draw this. Stop where it lies on the function, and then after that draw a perpendicular line here, and you can see that it intersects this halfway between 40 and 50, and that tells us the y coordinate in this case must be 45. And therefore the amount of money Adam has left after 132 hours must be $45. So this is part 1. Part 2 will be the number of days passed when Adam has only $10. You can just use the same strategy, or just substitute y equals 10 into the given function that you've just found, and you can just draw, in this case, a horizontal line intersecting the y-axis at 10, and then stop where it lies on the function, and then draw a vertical line, and you see that x is 9. That means Adam has $10 after 9 days. Alright, so that's how you kind of find the gradient and the equation of a given graph. Let's jump into the last example. Or for the last question, I decided to make a multiple choice questions, just because I haven't made some multiple questions in my channel before, so I decided why not just try it. So let me know if you guys like this type of question. So anyways, which of the following equations is more likely to represent the following graph? So given our choices right here, the only things that differ is the signs of the constants and the coefficients of x. To solve this problem, we only need to consider two things: the gradient and the y-intercept. And we must know that a positive gradient means the graph slopes upwards from left to right, which is in this case is. So that means the gradient must be positive. And for the y-intercept, and we know this is positive because it intersects above the x-axis, so that is also positive as well. And given with these two informations, the graph must be in the form of y equals positive plus positive, which is in this case option 2. Alright, next we need to find the equation of the function that is parallel to the line y equals x and passes to point 2, -3. So given those choices, so let's just solve it. We know that if two lines are parallel, their gradients are the same. So the gradient of our unknown, temporarily unknown equation of the function will be 1, because the gradient of y equals x is just 1, and to maintain that property, the gradient of our unknown line must be 1. And with this, we can just set up our Poinsel formula, and then after that, we can just substitute our given coordinates that lies on the function to solve for the y-intercept, and then we're done. We know our y-intercept, gradient is just 1, so it will look like something like that. And we have the points right there, so we can just substitute each x and y coordinate into the function. So the y coordinate is -3, and our x coordinate is 2. Solving this, we'll get that b is equal to -5. That means our equation of the form of the line must be equal to y equals x minus 5. And in this case, it is option 3. Alright, for the final multiple choice question of this third question, the value of a such that y equals ax plus a passes through the point 2, 6 is given those choices right there. And to solve this is pretty simple. And notice that y equals ax plus a can be factored. We can just factor out an a from this. We have a multiplied by the brackets x plus 1. And with this, we can just substitute our x and y coordinates right away. So the y coordinate is 6, and our x coordinate is 2, something like that. So I have 6 is equal to a times 3, which means a must be equal to 2. And that's pretty simple. So in this case, the answer is option 2. Alright, so that's it for this question and today's video. So hopefully you guys enjoyed this video. Please subscribe for more, and I'll see you guys in the next one. Goodbye.